Hey guys, welcome to your first video for Honors Math 2. Today, we're really going to jump right into Target 1A in Key Concept 1. Target 1A is all about similarity with transformation. If you watch the vocab video or looked at the vocab, you'll see we're doing a lot of transformations and dilations. One thing dilations have are scale factors, and we want to be able to solve for those scale factors. So let's look at example 1. Example 1 says, determine the scale factor given the center of 0, 0. So, I know my center. What you're going to do is just pick one of your points. So one letter. So I have J, K, L, or M. Let's use, Let's use L. Okay? So what I'm going to do is I'm going to count how far left or right, and then up or down L is from the center. So if this is my center, L is over 1, 2, 3, 4. Sorry, that's my center. 1, 2, 3, 4, 5, 6. L is 6 right. And then it's 1, 2, 3, 4 down. Once I have L, I need to find the dilated point as well. The dilated point is that L with the apostrophe. That means it's the second figure. It's not the original. It had to be given something else for its name. So L with an apostrophe, and it's pronounced L prime. So I'm going to find my distance to L prime. So I go over 1, 2, 3, right? So it's 3, right? And it's 1, 2, down. So now I want to find, once I know that information, I can find my scale factor. I'm going to abbreviate it, scale factor, SF, equals, it always equals the second over the first. So L prime comes second, it's not the original letter. So that has to go on top in your numerator. Now, I can choose either of these. I can choose the rights or the downs. It doesn't matter. So I just usually choose whichever one's on top. Yeah, it doesn't matter. You'll get the same thing whichever ones you choose. So, as long as you choose the same one. You can't choose like right up here and down there. You gotta choose the same direction. So I'm doing 6 right and 3 right. So, again, the second one goes first. So I have to start with that 3 right. And I'm going to divide it by the first, which is 6. And 3 over 6, right, as I reduce that, is 1/2. Right, I'm dividing both of those by 3. One thing to keep in mind, since this is 1/2, it's less than 1, so we call that a reduction. If it's getting smaller, it's a reduction. Alright, let's look at our second one. Determine the scale factor given center of 6, 3. So I'm going to go, right, that point's there. There's my 6, 3. So I'm going to do the same thing. Choose any point and figure out where it is in relation to that center. So I'm going to choose G. Right. So G is over 4. So that's 4 left. And then it's down 2, so 2 down. And then I have to do G prime, the second one. And G prime is 1, 2, just 2 left. And then it's 1 down, right, if you're counting there. So again, finding that scale factor, my scale factor equals, let's choose the downs this time, right? Kind of show you that it's the same no matter what we do. And again, second over first. So that's 1 over 2. And that's already reduced for us. It's 1/2. And again, since this number is less than 1, we call it a reduction. Alright, looking at example 3. For example 3, I still am determining the scale factor, but I don't have a graph, right? So I can't count how far it is. Right, for these, since they're not on a graph, you're really just looking at the length of them. I have 8 here, 16 here. I'm going to look at those two. Again, this is my first, this is my second. So I have to follow the same thing I did up there. Scale factor equals second over first, so 16 over 8. 16 divided by 8 is 2. Okay, so again, it's still just kind of that same division thing, but we don't have points, we just have length. And again, same type of thing. This one's now greater than 1, so it's an enlargement. We call it an enlargement. I always went on the phone. Enlargement is a much larger word than I think it is. So it's an enlargement. And again, that makes sense. It's getting bigger. Okay? Alright, we're going to skip example 4. It's the same exact thing as example 3. So let's look at example 7. Sometimes we'll have to graph a dilation. So looking what it says graph the quadrilateral J prime, K prime, L prime. So that's our new image after we've dilated it with a scale factor of 2, centered at 0, 0. Write the coordinates of the image in the space provided. Okay? So I'm going to put where our center is. Our center is at 0, 0. Okay? So we're kind of using the same thing in reverse as what we did last time. I still need to know where J, K, and L is, how far they are from the original point. So starting with J, J is 1, 2 right, and then it's 1, 2, 3, 4 up. J is 2 right and 4 up. Now I know my scale factor is 2, right? I have a scale factor of 2. What that means is I'm going to multiply these by 2 to get my new point, J prime. So J prime is then, right, 2 times 2 is 4 right from that middle, that center point, and then 8 up. Okay? So J prime is 4 right and 8 up. I just multiplied its distance by that scale factor. And I'm going to do the same thing for my other point. So K, right? If I look, K is 1 right and 1 up. I'm going to multiply both of those by 2. Because that's my scale factor. So my new point, right? 1 times 2 is going to be 2 right and 2 up. Okay? So 2 right and 2 up. Sorry, I forgot to put the K prime. And then we have L. If you look, L is 1, 2, 3, 4 right. 0 up. 0 up. Right? And again, since my scale factor is 2, that's what I'm going to multiply by. So L prime is 8 right of the center and 0 up from the center, right? So all of these points have to do with where our center is. This problem is like the easier version of it because our center is at 0, 0. It makes it nice and easy. Okay. So J prime is just over 4 up 8 from that center point. So that's J prime. K is just 2 right, 2 up. That's K prime. From that center point, which is 0, 0. And then L is 8 right, 0 up from that center point. So that's out. So then I'm going to connect all my points. Right? And then I can write the points in. Since it's at 0, 0, again, that makes it easy. 4 right, 8 up, that's 4, 8. 2, 2. 8, 0. Right? It really makes writing those points in a lot easier. If it's not at 0, 0, then you really do have to look at what your points are. Like the next example we're going to look at. So go ahead and turn the page. And we're going to look at example 8. And that's the last example we're going to look at for today. So complete A, B, and C using the coordinate plane below. So I want to graph. First I want to graph KLP with the vertices. So this is my original image. So K is at -4, -6, which is here. So -4, -6, so that's K. L is 0, 4. And then P is 4, -6, so over 4, down 6. Right. And now I'm not just graphing these points, I'm graphing a that's P. I'm graphing a triangle, so I do have to connect my points. Alright, now I'm going to transform this with center to 2. So 1, 2, up 2, over, or right 2, up 2, right? That's my center. So that's what you got to keep in mind. So if I want to transform the point K, K is at, from this point, I have to go over 6. Why is it doing that? Over 6, right? And you can count those. So 6 left. And then it goes, if you count, it's down 8. And then my scale factor is 1/2. So that's what I'm going to multiply by. So 6 times 1/2 is 3 left. Abbreviate a little bit. 8 times 1/2 is going to be 4 down. I'm just putting the first letter of the direction to save some space. Then for L, right? L is here. From that center point, it's 2 left and 2 up. So again, you're always starting back at that center point. Again, I'm going to multiply these by 1/2. So 2 times 1/2 is 1 left, 1 up. And finally, I have P, right? And if you look, P is 2 right. And then you can count, it's 8 down. And again, multiplying that by my scale factor, which is 1/2. 2 times 1/2 is just 1, and that's going to be right. 8 times 1/2 is 4, and that's down. Right, so now I'm going to graph these new points. Right, so K prime is from the center. 3 left, 1, 2, 3, 4 down. 1, 2, 3, 4. It's right about here. Right? That's K prime. L prime, from that point, 1 left, 1 up. Here. L prime. And P prime, from that point, is 1 right, 4 down. Okay? And then I'm just going to connect all of those lovely, lovely points. And that would be my new triangle, right, once it's been dilated. Okay. We're going to talk a lot more about dilations and scale factors tomorrow in class. So come in with whatever questions you have.